Very good. So, well, good afternoon, everyone, and thank you very much for the invitation to present here. This will be a bit of a different talk from the previous two, and is somehow, is almost frightening to talk after such a good selection of speakers. And following an invitation from Antje, mine is more of an opinion piece, if you want. So there is no really new result in what I'm going to say. It's a bit of a reflection on where we are in terms of climate services and the information we provide to the users, seen from an operational climate service such as Copernicus Climate Change Service. As you see, my slides are blank because in many cases, these are my own opinion and no one else should be made accountable for what I'm going to present. The background you see in my camera is the one of Vienna, where I hope we will meet again next year when the COVID finishes. All right, my talk is divided into three acts. The first act is quite light touch and is a bit of a historical perspective. So if you need a cup of coffee or something, this is the time. The second act is more about the experience of C3S. And the third act is a bit of a way forward or a reflection opening to an epilogue. So how did it start? I think it started largely as an academic exercise. So we can go back to Arrhenius, so we can pick up this famous paper that has been recently identified by Carbon Brief as being the most influential climate change paper of all time. But we can say that doesn't quite matter, and the historian of science probably will correct me on this, but we can certainly say that sometime in the middle of last century, we started to look at climate and climate change more seriously. And then we spent the following 50 years arguing that actually climate is not, and climate change science is not just an exercise, not just important for society, but it's so important that the data that underpins this science actually can inform policy and is very much needed. And the fact that the first report was probably 180 pages long and the last one probably 180 pages is the average chapter these days, I think is quite significant in showing how much the agenda has changed over the years. But there is another development, and we heard just before me from David about UKCP 18. There's another development, and it's what is happening at country level. And this is very important in the sense that it's going beyond the science and it's trying to transform the climate into data for, or climate science into data for application. So if you look at what has happened in UKCP 09 and then UKCP 18, but also what has happened with the climate scenario for Switzerland or the KNMI 2014 projections, in all those cases, an effort has been made, a significant effort has been made to go beyond the model output and try to understand the user requirement and provide the data and the information in a way that it was useful and usable. There is a catch, and what I call the jungle, which is the fact that especially if you don't operate at country level, if you operate internationally, if you are a big multinational company, if you have assets distributed over a catchment like the Danube that you see in the plot, well, the exercise I was referring to before doesn't quite work in the sense you don't have a unique reference set of simulation, and you have the jungle. You have information coming from different MIPS, and in this last round there are quite a few of them. You have information coming from RCM and GCM and GCM combination, and the matrix of codecs in this case for North America is quite interesting in that respect. And you have observations such as the one, for instance, coming from satellite or from reanalysis or from ground-based station. So how do you put those together? How do you make sense of all of this in a consistent way? So that was a very quick introduction. Act 2. Act 2 is very much about the operational climate service. And this is interesting. I'm clearly talking about Copernicus because this is what I know best. And I'm particularly picking up something that is not related to model simulation, but is very much linked to observation, because observation are a crucial part of the equation here. And what is interesting for me here is in this case, this is not research, it's completely detached from research. Copernicus Climate Change Service is an operational service aiming to provide data and tool to users. And center of CTS, you may know, is the so-called climate data store. And on the climate data store, we now have some 40,000 users, and we deliver roughly 50 terabyte of data per day, which is not dissimilar as an order of magnitude to the data that is delivered and downloaded from ESGF. And is a combination of CMIP simulation, it's going to be CMIP6, CMIP5, and Cortex, but also seasonal prediction, observation, reanalysis, and the like. And if you look at the profiles, we have a good analysis of who the users of the climate data store are. You see that vast majority still comes from research, but there is a growing part that is coming from other part of the community, and in particular the commercial and private sector, which now represent almost a fifth of the overall number of users. These are not, this number are not based directly on the CDS users, the climate data store users, but they are the respondents to a survey we launched at the end of last year. Nevertheless, 1 in 5 basically represent a private sector. So these are users that are beyond the climate community. And with these users, we actually engage in a dialogue, in an interaction, quite close interaction, try to understand how they operate, what they need to develop specific services. So there were 10 sectors that were mentioned in delegation agreement of C3S with the European Commission. And for each one of these sectors, we develop one or more application. Most of them run on the climate data store and produce interfaces, data, advice, and information to the users. More importantly, in this interaction with the user, we really try to capture the user requirement in a very detailed way. So a big part of the program is so-called the evaluation and quality control, the EQC part, which is largely invisible at the moment and will become more visible within the next couple of months. And is crucially provide information on the quality of, or provide quality brief about any data entry to the catalog, but very importantly also provide a user requirement database, systematic collection of user requirements from all these sectors that are then analyzed and used as a way of informed service evolution. So if you look at this user requirement, you realize that there are new users and there are new requirements. Clearly, it's beyond the scope of this talk to get into the details, and hopefully there will be many other occasions in the future. But I just want to highlight a few requirements that are emerging, or just this slide, but a few requirements that are emerging that are really different from what we've seen before. So if you look at the effort that is currently ongoing in terms of standardization and climate adaptation, so the ISO standard for climate adaptation, 14090 or 4091, underpinning this standards, there is a requirement for good quality data, reliable data that is produced operationally and is provided to the user. And the same can be said, for instance, for the task force on climate-related financial disclosure that is becoming more and more important and is a key requirement that many sectors are now relying upon. Or more generally, if you look at the Sustainable Development Goal, in all those cases, there is a requirement for data, for reliable data, typically at a global level, beyond the national boundaries, that is provided operationally and is not part necessarily of a research exercise. Which leads me to the Act 3 of this talk. So I think we can call it an incomplete journey from research to services. So we started in the past as almost entirely as a research activity. And now we see that there is a growing, also because of the effort that we put into it, there is a growing need for climate data for all sorts of sectors of society. And this has been, has been acknowledged by, for instance, by the SGF. If you look at the architecture workshop back in November, it's clear, and is, as is stated on their document, that the use of ESGF has changed because the landscape has changed, and there are many many functions beyond CMIP. These also been picked up by WMO with the resolution 67, which look at how to enhance the research to operation linkages of CMIP. So there is a landscape, and at least at the infrastructural level, this is being reacted to. Yeah, I'm getting to my conclusion quite rapidly. The point I'm arguing is that these changes in the landscape require a profound rethink of the way in which the climate simulation not only are delivered, but are put together and designed. And this needs to be done at international level. So maybe we are not far from the moment we can go beyond the kitchen sink. So just to conclude, I would say that we need a different data governance and a different data infrastructure to better account for the rapidly growing non-academic use of the data. So the academia is no longer, or is still, looking at our statistic, the primary audience, but is other audiences are growing very rapidly and they are becoming more important. And the issue is not only how to make tens of petabytes of data useful and usable by a large set of users, but it's also how to generate the data in the first place, both the observational and the model data, and how to combine those in a way that makes sense. So I think we are not far from a moment where we'll see a divide between sort of a research layer and an operational layer. And I guess the point to offer to the audience is how we should, well, that we should reflect on how to best make the transition toward this new setup. Thank you.